Good morning, geometry. Today we're going to learn about tangents to a circle. I have a circle. Now when I have a line that intersects a circle, it's possible that it's a tangent. A tangent intersects a circle in exactly one place, one point there. If I cross the circle, I have a secant line. Okay, so that's the difference. We have a tangent and we have a secant, and then we just have a line. When you pull tape off of a roll, generally it's not a tangent because it's sticking to the edge. However, if I'm putting tape on a roll and rolling it this way, I may have created a tangent. So as I was thinking about tangents, I was seeing a lot of tangents in a lot of places, and this is one place where you might have seen a tangent before. Is when you're spinning something around. Of course, that's a circle. But then you let go, and then it flies. There's a tangent. When you spin something in a circle, and then you release it, what happens is that at that point of release, it goes in a straight line as if it traveled in a straight line to get there. So basically, it would be like as if at that point it didn't have any knowledge of being on the circle and it just continued in a straight line. That's a point of tangency. When you release something after you spin it in a circle, it's going to be going off on a tangent. We're going to learn a lot about tangents, what we can find out with tangents. So remember, a tangent is a line that intersects a circle in one place. A common tangent would intersect two circles. And so let's go ahead and see what that would be. So it's a line that intersects two circles in one point. So if I drew a line across here, I could probably balance a line across the top of the circles like this. Now, if those intersect the two circles in one point each, that's called a common tangent. So there we have a common tangent. There are different kinds of common tangents. This one is called an external tangent because it doesn't go between the circles. It doesn't get in their way. It basically just goes on the same sides of the circle. That's called an external tangent. And there should be another external tangent down here. So there are two external tangents to these two circles. Now, if the line goes in between the two circles and separates them, it's called an internal tangent. So an internal tangent actually comes between the circles, so one's on one side and the other's on the other side of the line. There should be two internal tangents in this case. Now, there are the internal tangents. So these are the two kinds of common tangents we have when it comes to circles. The next thing we're going to look at is called tangent circles. So not just a line can be tangent to a circle, but a circle actually can be tangent to another circle. This circle right here possibly touches that circle in one point. That would be tangent. If it touches it in 2 points, it's not tangent. Now, there's two possible cases. I show one over there, but I could touch the circle from the inside. This would be an internally tangent circle. These is external tangent. Tangent circles are two circles that intersect in one point. So I have 1 point there, I have 1 point there. Let's take a look at the tangent circle theorem. The tangent line to a circle theorem says that if I have a tangent line to a circle, and suppose it intersects the radius. So there's a radius and they intersect. We've already seen this before, but that has to be a line of symmetry. So therefore, that has to be a right angle. There's no other way about it. Now, if I had another radius in here, it's possible that it's not perpendicular to that line. But notice that it won't intersect that line either. So this says if a tangent intersects a radius, then they must be perpendicular. Okay, well, we could use this property in a number of ways, and we're just going to check this out here we have a circle and we have a line ST. It says in the diagram, PT is a radius of circle P. So this is the center of the circle. And is ST tangent to P? So we're just going to determine if this line is tangent to the circle. Now it's harder to tell if we have a line segment that's tangent. Over here we could kind of tell by the diagram that that's a tangent because it intersects in one place. So right down here I have our case with the tape. So like this piece of tape, as I'm pulling it off, it's sticking there. So this is actually not a tangent because if I continued that line, it would not touch the circle in one place. But suppose that I'm pulling the tape off and that would just continue past. I could say, well, if I knew where that point of tangency was and I drew that line, this would be a right angle. If I did that same experiment with this one, there's the center, there's the radius, that's where they intersect. That's not a right angle, so therefore this is not tangent, but this is tangent. Okay, we're going to use that property here, but our given information is about lengths. We know that's the center. And how do we determine if that's a right angle? Well, we have the Pythagorean theorem because this is a triangle. And we'd say if a squared plus b squared equals c squared, then angle T is a right angle. That's basically the idea here. So we're going to determine whether that's a right angle by plugging that into the Pythagorean theorem. Maybe I should look at this. This would be my hypotenuse, my longest side. So I'm going to call this side C. This side I'm going to call A, and this side I'm going to call B. So I'm going to plug these in. Now A is not given. However, we are given the information here. The 12 should go from this point to that. So this is a radius. And that radius and this radius must be congruent. So therefore, this must be 12. So this would be 12 squared. Let's look at B. B is given. That's the 35. And the C. Now, the C is the whole thing. 25 plus 12 equals 37. So this would be 37 squared. We have 1369 equals 1369. So therefore, T is a right angle. If we're going to answer the question, is ST tangent to P? Yes, we know because that's a right angle. Here's another way to look at that same kind of problem is we want to determine, in this case, we're given the same information. PT is a radius, circle P, this is the center then. ST is tangent to P, so we know this is a tangent this time. So we're given that it's a tangent. Find the radius of P. So the radius is not known, but one thing we know is that this information, ST is tangent to circle P, means we have a right angle. Now we're going to just use this property and the fact that those are two radii of the same circle. So now we can use the Pythagorean theorem that a squared plus b squared equals c squared and plug in our different sides. So let's use r squared as our radius, and b would be the 80. And then the c would be the sum of these things, 50 plus r. So we have to add those together. I'm just going to use r plus 50 because that's a little bit more standard. R plus 50, put the variable first, and I'm going to square that. Okay, now we're going to have a little bit of a trouble here if we forget our algebra. So let's go ahead and remember that there's two ways to do this. One of them is using the box method, and I'm going to write it down here, r and 50. So when I multiply out a binomial, I have to remember that I'm multiplying two things by two things. So this is really r plus 50 times another r plus 50, and we really have to distribute both the r and the 50 into those things. So we could also use the FOIL method here. I'll just write this down in case you know what the FOIL method is. We'll look at that first, outside, inside, last. and that gives us our FOIL. In this case, we just multiply this out like a multiplication table. So r times r, remember, is r squared. R times 50 is 50r. And then I have another r times 50, so that's 50r. And then 55 times 50 is 2500. So that's what happens when I multiply this out. Usually in this case, we can combine some like terms. So when I multiply this out and then combine those terms, that is 100r in the middle. So I get r squared plus 100r plus 2500 on the right-hand side of the equation. And the left-hand side is r squared plus 80 times 80 would be 6400. Okay, this looks like a complicated equation, and it could be, except that we have a special case here. When we subtract r squared from both sides, they actually cancel out and they're gone. So that makes this problem a bit easier now. We have 6400 equals 100r plus 2500. Go ahead and solve for r here. Okay, we get r is 39 in this problem, so that's our answer. The radius of this circle is 39. Okay, there's one more property with tangents that we're going to be using quite often, and this sometimes I call the hat rule, or you could call it the ice cream cone rule, but it's basically the idea that we have two tangents to a circle. These are external tangents, and they intersect at an external point here. And what's the properties? One thing we can think about is that there is a line of symmetry. We can find the line of symmetry, and that means that these segments are congruent, and that's basically exactly what we're going to do. We're going to look at those congruent segments. It says if tangent segments intersect outside a circle, then they are congruent. Let's make a note here that this segment, we're talking from this point to this point. So really the tangent segments that are congruent, that would be this segment here and this segment here. All right, let's go ahead and use that property now. In this first case, we're just going to write an equation that we could use to solve for x. So these are two tangent segments. That should be a segment there. Find the value of x. So we know that these are both tangent at S and T, and therefore this is congruent to this. So go ahead and write an equation and solve for x. So x should equal 8. You could plug it in here and double check. 3 times 8 is 24 plus 4 is 28. This is kind of an interesting problem right here. We have tangents, 4 tangents to a circle. They all intersect at these exterior points. We know some information about their lengths, and we have to find out how long this one is, and it doesn't seem like there might be enough information. But once we start working this, we'll see that there is. First of all, we have to assume that these are tangent, and I don't think we have the directions that say that, so we're just going to assume that there's 4 tangent points. And whenever I have the tangent points that intersect outside a circle, I know I have congruent segments. So we can probably find those congruent segments around the circle. This one right here is 3, so this has to be 3. So I'm just going to start putting these things in. That's got to be 3. I'm not sure what this is. That's 3 altogether. It's not in the middle. That's 5. I could work around this way. That's 4, so we know we have a 4 right here. And if this is 5, 5 minus 4 is 1, so that's 1. So we have 4 plus 1 is 5 for that side. And then if that's 1, then we know we have 1 over here. And if this is 3 and that's 1, we have a 2 here and a 2 here. And now we have x. X equals 3 plus 2, this side right here. So x equals 5. I hope you learned a lot about tangents today. I'd like you to go out there and look for some tangents. Check it out. They're everywhere. All right, have a great day.